Welcome to Lesson 316, Equivalent Expressions. Today we're going to talk about how to identify equivalent expressions and how to create equivalent expressions. Alright, so before we talked about how to simplify expressions by combining like terms, so now what we're trying to do is we're kind of doing the opposite and we're expanding the expressions. So originally I have 8 times a. I want to find expressions that will be equivalent to that. So they're going to look different, but they're going to give me the same answer. So in this case, I took 8a and I split it into 4 times a plus 4 times a. Another way that I could do this is to take the 8a and I could split it into 2 times 4a, because when I simplify it, it goes to 8a. I could break it into different like terms and I could make it 3a plus 1a plus 4a. I could split it into 10a minus 2a. So we're just finding different ways to get to that 8a. So what I want you to do is I want you to take a minute and I want you to try a couple of these on your own and see if maybe you come up with some of the same things that I do. But either way, you have to make sure that when you combine your like terms, all you end up with is 8a. All right, so here we could also break it down into 2a, sorry about that, plus 2a plus 2a plus 2a. I'm running out of space here. Could also turn it into 2 cubed times a, or a plus 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 a. Or we could break it down into another subtraction one, so we could do 18a minus 8a. I apologize, minus 10a. We're trying to get 8a. Okay, so all of these would be equivalent to 8a. It's just a matter of breaking it apart the correct way. Okay, so when you're doing this, I want you to create 3 equivalent expressions for each of the following. Now, the thing is, here is your expression. You can use the distributive property to create an equivalent expression. Then from there, create another equivalent expression. It's kind of like when we work with fractions and we say find equivalent fractions to 7/14. Well, instead of just doing times 2 and getting 14/28, you could also simplify it and turn it into 1/2, and then you could get numbers like 2/4, which you couldn't get from 7/14. Okay, so don't be afraid to change it and then make an equivalent expression from the expression you created. Right, so you're going to do that on your own. Now here we're going to determine if the expressions are equivalent or not. So here we have to use the distributive property. Now remember, we have to share the 5 with the t, and we have to share the 5 with the 9. So we get 5 times t plus 45. Well, is that equivalent to that? Our answer here would be no. Okay. And then I'm going to come down here and do a more complicated one with you. So here you have 2 times x plus 5t. Is it equivalent to 3x plus 2t minus x times 2t? Okay, so in this case, I can combine like terms with 3x and x, but since it's a minus x, it's going to be 2x plus 2t times 2t. Okay, well, that's not necessarily going to work because that's not going to get us to 5t. We don't even have to go any further because there's no way that 2 times 2 no way that it would work to get us to 5t. So we know that that would not be equivalent. So you have to use the idea of combining like terms and the distributive property to see if these would be equivalent or not. So I want you to try the last three on your own. And as always, if you have any questions, please be sure to post them to Edmodo.